Hello developers! In this video I'm going to present you Spring Native microservices with GraalVM, and that means having a lightning fast start of your application in the cloud. So let's first talk about the GraalVM, which is essential for Spring Native images and the lightning fast start in the cloud. So GraalVM is a Java virtual machine and a JDK, a Java development kit, and it's available in the Java versions 11 and 17, which are the current long-term support versions. Oracle develops GraalVM and offers it as a free community edition or as an enterprise edition that requires a license. Since version 19 in May 2019, GraalVM is ready for production and you can use it in the same way as you use any other JDK and can expect the same quality from it. So what is the great thing about GraalVM? GraalVM has a new killer feature, and I would call it the ahead of time compilation. So it's the AOT compilation of the source code. So the big thing about it, you can build with the ahead of time compilation a native image within the build phase of your build tool, like Maven or Graal. Native images contain all required application classes, dependencies, third-party libraries, and JDK classes. And therefore, the native image is a standalone executable binary, which offers a significantly faster start of your application by having lower memory consumption. If you compare it with the classic compilation of the regular JDK, I did this here, and here that is a picture which explains it. So here you can see on the left side the ahead of time compilation compared with the classic just-in-time compilation. So when you see the difference, the ahead of time compilation offers you a faster startup of your application. It has a lower memory footprint, so that are the advantages compared to the classic JDK. And the classic just-in-time compilation offers, on the other hand, a higher peak throughput and a reduced maximum latency. So that are the differences, and it depends on your use case which one is the better JVM and JDK for you. But if you develop microservices for the cloud and you want to scale them rapidly because you have spontaneous growing load peaks, then the ahead of time compilation and the native image have a great advantage. The installation of GraalVM, it is super simple. It works in 3 steps. You have to download it, you have to unzip it, and you have to configure it in your IDE, and that's it. Then you are good to use it. It works in the same way as any other JDK. So if you are interested in the details, here you can find the link. One thing, if you want to have a native image, it has already the word image. It's some kind of a Docker image, so you need Docker installed on your workstation, on your PC or notebook. The explanations about how to use Java applications with Docker and how to build images in general and how to install Docker. Therefore, I have linked another blog article of mine, this one. Feel free to check it if you need this information. Otherwise, if you have Docker already in place, you can directly go on to build the Spring Native images. So Spring Native means it reports native images and it builds them with the GraalVM. So therefore the Spring Native images have the same advantages as in general the GraalVM. You have the lightning fast start of your application, and you are immediately ready with your Spring application to deal with spontaneous coming load peaks because your Docker containers are starting so fast. And of course you have the low memory consumption compared to the traditional classic Spring application. As you see this video, in November 2022, Spring Native has not released a version 1.0. Nevertheless, I expect that we will get this in this year with the release of Spring 6 or Spring Boot 3 or both. I guess both will happen at the end of 2022. So there I expect also to have Spring Native as the 1.0 version. Okay, so next thing I explained here in the blog article is how to set up a Spring Boot project for GraalVM and to build your Spring Native image. Therefore you can use the Spring Initializer. You use it in the classic way. I select Maven as project, Java as language, but could be anything else. Version 2.75, that is the current latest version of Spring Boot, so I'm just using it. Metadata, feel free to use whatever you want. Packaging jar, Java version 17, and then I choose the dependencies GraalVM native support, so that is required for Spring Native. It is Spring Native, and for demonstration reasons I want to offer in my application a REST API, so I'm using Spring Reactive Web to have a web application, to have a REST endpoint. If you are interested in more details about Spring Reactive Web, check out this blog article. It's also linked in my Spring Native blog article, and here you find details about building REST APIs, reactive REST APIs with Spring Web Flux. Okay, then you can click on generate and you will get your Spring Boot project downloaded as a zip file. You can extract it and you can import it in your IDE and use it, or you can use the wizard of your IDE to set it up inside the IDE directly. That's up to you, whatever you prefer. And here I have my project already prepared. It's called GraalVM, and it is more or less nearly a plain Spring Boot project as you get it if you have generated it. So for example, here we have the GraalVM application class, and that is just the classic start class as you know it from any other Spring Boot project, so nothing special about it. I created one class, demo controller. This one is offering my REST endpoint, so it's just a REST controller listening to HTTP GET requests on the path /demo, so localhost 8080/demo, and then this method will be executed and return some kind of hello world message. There's also nothing special in my application properties. Okay, so the application name is a value which I read from the application properties. So you see it here, so it's a hello world or a hello agilecoding.blogspot.com, and this is just an adaptation of the logging format so that we have a more compact logging. But this could be also empty. That has nothing to do with Spring Native. The only thing which is special to Spring Native is the Maven configuration or the Gradle configuration. Here we have a Maven configuration. But first of all, it's a classic Spring Boot project. So we have the Spring Boot starter parent POM. We have a version. We define Java 17 as Java version. Yes, I'm using the GraalVM. You can see it here, the JRE system library. It's GraalVM Java 17. So this project is executed with GraalVM, and the dependencies are also as we selected it in the Spring initializer. I removed here the test dependencies to make it more simple. But one special thing to be mentioned here, the Spring Native is today, as I make this video, still an experimental library, so it's not released as version 1.0. So today we have the version 0.12.1 active, but as I said, I expect that this version will be the 1.0 version in the very near future, because with Spring 6 we expect that Spring Native is part of the Spring framework as a regular feature. Okay, then here we have details about the build, but before I start the build, I will just start now the application regularly as a Spring Boot application. Well, let's have a quick look at this. So here you see it's started, the ahead of time compilation mode is disabled. It's a Spring version. You can see the start time 2.979 seconds, so that is not lightning fast. That is just the classic way to start a Spring application, and here we have the GraalVM as JDK and as Java Virtual Machine. So yeah, really nothing special about this at the moment, but feel free to check out the GraalVM homepage to get more details why it might be also a good idea to use GraalVM in general, but that is not the scope of my video today. Today I'm speaking about the native images. So let's get back to the Maven configuration and see what is special in the Maven configuration and how we get the native image. So here in the build we can see that we have now here adaptations to the Spring Boot Maven plugin. We have defined a builder for an image, and here I'm saying the first time that this is a native image. Oh no, it's not me saying this. This is the default configuration as you get it from Spring Boot. So you don't have to take care about that if you want to use it. There's another plugin which is making sure that we have the ahead of time compilation. So it's a Spring ahead of time compilation Maven plugin. It's in the same version as Spring Native, and it's triggered with the goal generate. So this is also an experimental dependency. So we have now two experimentals, this dependency and this plugin here. So therefore we need repositories defined in our Maven configuration. This one for the dependencies and that one as a plugin repository. It's the same one. So the experimental libraries are not in the official Maven repository, so therefore we have here to use the Spring Releases Spring repository, as you can see it here. And finally, there is a profile called native, and it's also executing a plugin, the native Maven plugin, and this one is also part of the phase package executed with the go build, and it's making sure that we build a native image. So let's do this now. Let's build a native image. So here I prepared a Maven command in my IDE. So I'm doing a clean and then the Spring Boot build image command. And if I do Maven clean Spring Boot build image, I will build now a native image. So I click the run button. And let's look into the console. Now it starts the regular Maven build and it will build me a native image. This process will take several minutes, so I make now a break in my video and continue when it's done. Okay, so the build is done. So let's check the logs of the build. I was building my application GraalVM in version 0.6, and here it started as the classical Maven build by compiling the sources, and after the tests, which have been skipped here, the building of the image started. Yeah. So here we can see, first of all, it's going to build GraalVM in version 0.6, so that is our native image, and it fits of course to the values we have stored here in the Maven configuration. First of all, it's downloading other images to build our image. That is happening here. It takes some time, and then here the build process of the native image starts. We are getting here some details, and after a while it's having a lot of details. But after a while, yeah, we are doing the analysis of our source code. That is ahead of time preparation. It's building everything, parsing every methods, doing inlining methods, compiling methods, finally creating the image, what we can see here. Yeah, you get also some statistics about the image, and then it's done. And as you can see here, the total build time of a native image is relatively long. Yeah, so it takes a long time to build a native image. So let's check it out now. So I have Docker installed. So first of all, right now no Docker containers are running, but I have now some Docker images here. Of course, we have the GraalVM image in the version 0.6. That is exactly the native image I built right now with my Maven build. Yeah, so this created 42 years ago. That is just some issue in the building tool. Of course, we built it right now and not 42 years in the past. Anyways, we can see here also some more images, and that are the builder and runner images to build the GraalVM image itself. So let's do now the next thing and start it. So I'm using here Docker run. I make a port mapping of port 8080 to port 8080 so that we can reach our application, which is listening on port 8080, which is the default of Spring Boot, and here GraalVM is the name and the version. So let's start it, and as promised, it is super fast. So we can see here started GraalVM application in 0.051 seconds. So it's it's 1/20th of a second. So it's super fast compared with the starting time of the regular Spring application I have shared with you before in my IDE, which was around 3 seconds. Yeah, so that is really super fast, and that is the killer feature of the Spring Native images. So let's check out in the browser if it's really working. Localhost port 8080/demo, and then we see here the result, hello from agilecoding.blogspot.com. So that is the answer for my native image. Let's do it one more time, yeah, to see again how fast it is starting. Therefore I have to stop first my Docker image. So let's do this again. Now with the shell, it started here in 0.046 seconds. Now I can kill it because I have the shell now. Start it again. 0.053 seconds. So that is about the classical starting time, and here you can see it's up and running. Yeah, so let's get to the bottom line of this whole thing. The great thing about Spring Native and GraalVM is that you have this kind of lightning fast start in the cloud. It's way more than 10 times faster than starting a classical just-in-time compiled the Spring application. So this is really something which gives you a great opportunity to scale super fast your application, to set up 100s of Docker containers based on your Spring Native image if the current load requires that. On the other hand, if you don't need this kind of scaling, then of course you can still use the classic Java virtual machine or the classical Oracle JDK or OpenJDK, which has also its advantages like the better peak throughput. But that's now up to you. You have two possible tools with different strengths, so feel free to choose what fits better to your use case. That's it for today. If you liked my video, please give me a thumb up and subscribe to my channel so that you get informed if I'm offering more new videos to other interesting topics in the Java, Spring and Cloud world. See you next time.